Hi everyone, welcome back to Adrian's Digital Basement. Today I'm going to talk about this Mac IIci I recently acquired. I got this computer locally for just 15 bucks. I've actually wanted a Mac IIci pretty much my whole life actually. My father had one of these for his business when I was a kid and I lusted after this. But when this computer came out in 1989, I think it was around $7,000, which is the equivalent of $12,000 in today's money, a little bit unaffordable for a teenager. So when I picked up the computer, it was in a non-working state, which I anticipated, and I just figured it'd be a fun project to try to get this computer working. Let's take a look. Physically, the computer's in really good shape. It's just dirty, but there were numerous problems. So I wasn't sure I was going to make a video about this computer, so I've already done some work on it, which is why it's in the state it's in at the moment. You might be wondering what the heck is going on with the power supply. Well, right off the bat, this computer had what I call the click of death. So essentially when you turned it on, it would just go click, 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 kind of like a zip drive. And it would power cycle essentially on and off constantly. This is the original power supply itself that I took out of the computer. It was sort of a two-piece deal, layered sandwich like this, really difficult to work on. It's actually really hard to even get out of the computer. I started doing some research on this power supply, which I think is used on the IIcX and the IIci, and I found posts of other people having the exact same click of death problem. And of course, everyone said, recap it, recap it. So those people went ahead and recapped it and found that that actually didn't fix the problem. I was unable to obtain schematics for this, and I'm certainly no power supply expert. So if the problem is more than just recapping, I'm probably not going to be able to figure it out. So I decided to not waste my time and just move on. This chassis is shared between the Mac IIci, IIcX, and the Quadra 700, so the power supplies are all interchangeable between those machines. Unfortunately, it's hard to find these computers, any of those computers at this time, so I decided to just swap in an ATX power supply into the case. I'm not going to talk too much about how I did this. Essentially, I just took the guts of the old one out, put the new one in, hacked the power connectors together. I haven't finished with the work, which is why you see the original ATX power supply here, including the jumper that turns on the power supply. But I'll have a little bit more work to do to properly mount this, isolate it so nothing's going to short out, be safe, and it also needs a fan installed. But for the most part, I did this just to see if this computer even powered up at all. When I opened the computer, I was absolutely ecstatic to find that not only does it have a NuBus video card in it, it had 8 megabytes of RAM installed, and a 68040 accelerator card with a cache memory expansion. I haven't delved too deep into this card, but it's a 33 MHz 68 EC040, which is the type without the math code processor, but the chip is in a socket, so I could swap it out for something else. And the crystal oscillator here seems to be a doubled variety. It's 16 MHz. I think the processor may double it internally. I'm not positive on how that works exactly, but ultimately if I want to upgrade to a 40 MHz, I just have to swap the crystal out. And if you see here, it's got the 128K cache memory added on as well, which is really nice. And there are some jumpers in here, down here, that allow you to configure which type of 68040 you're using. This accelerator card is made by Mobius Technologies from 1993, and it's their Speedster card. The NuBus video card that's installed is made by E-Machines, which is actually, or was, a local Portland company that made Macintosh video cards and monitors. I can't really find much information on this card. It says E-Machines Inc. 1988. And on this part of the board here, it says Z71 controller, has some part numbers. If you notice, the serial number there is just 911. But it uses the 13W3 video connector, but as you notice, there's only one coax connector there out of the 3. That means that this is a grayscale card. Most likely this was for driving a large format monitor, probably doing CAD work or desktop publishing. If you know anything about this card or E-Machines, let me know. Putting it in the computer, it boots up, but doesn't seem to do anything, although I don't have a way to connect a monitor to this, so I really can't test this properly. The machine actually had a working hard drive when I got it, 105 megabytes. It did boot. It booted to System 7.1. It had the drivers for the 040 accelerator. It also had the control panel driver for the NuBus video card. Also had some CAD software and a few other bits and pieces of software on there. Unfortunately, after using the computer a couple times, the hard drive died. So that hard drive no longer works at all. I've done extensive troubleshooting on it. It spins up, but it's not recognized by anything. So I've given up and cut my losses on that hard drive. I was lucky enough to think ahead, and I copied the 040 accelerator drivers onto a floppy disk just in case the hard drive died, and it did die. Unfortunately, though, I didn't copy the video card control panel, which was the only other thing that really was unique on that hard drive, and now it's lost. One other small thing is, of course, the PRAM or CMOS battery was dead in this computer. It uses a little lithium battery. Luckily, those don't leak. Traditionally, a little barrel battery. So I have just temporarily clipped on CR2032 here in a battery holder, just to test to make sure that that part of the computer actually works, if it keeps time and stuff, and it does. I'm going to end up just installing this CR2032 holder kind of on top of the socket that's in there where the barrel battery is. I find buying those little batteries is just silly. They're expensive. I can buy 20 of these batteries for the same price, so I'll do that. It's much simpler. Oh, I keep forgetting too, there's a few more things. The floppy drive was all gummed up with dirt, which is typical. This computer was really dirty inside and well used. So I took it apart to clean it, lubricate it, get all the gunk out of it so it would, work properly. And unfortunately, the eject mechanism is messed up on it. And it's not that the gears are stripped, which is a very typical problem on these Macintosh floppy drives, is that for some reason, the motor doesn't have enough power to actually eject the drive. So while the mechanism works very smoothly, you put discs in and out and works perfectly, when it tries to eject, it's like, and just stops. If you know anything about the eject mechanism on Macintoshes, there's a little motor and a gear assembly, and there's a small little metal contact switch inside of that assembly, so that once the eject sequence starts, it actually runs an entire cycle all the way through so the disk comes out of the drive. That contact was actually screwed up, and when it started to eject, it would always just stop midway through. No more power was getting to the little motor. So I took it apart, which is very difficult and it practically breaks it, cleaned up the contacts and bent it into shape so that it would work again. But unfortunately, after putting it all back together and lubricating all the gears, now it has that problem with not enough power. So because I wasn't sure how to fix that, it was easy for me just to swap the disk drive out with another one. I had a Centrus 610 computer that had been totally destroyed, but had a perfectly good floppy drive, so I cleaned and lubricated that, and that's what's in here now, so I have a good working floppy drive. Alright, so let's power this up and I'll show you how it works. So when I turn this switch here, you get the power light, we get the hard drive spinning up. My monitor came to life, so hopefully it boots. There we go. And I got I have an ADB mouse connected, and there it is booting. So the computer boots up and seems to work fine. Got 8 megs of RAM showing. I'm running System 7.1 on here. This is a hard drive I took from a different computer and reinstalled the OS on it. And since I saved the 68040 control panel for this Speedster card, I can now manipulate this as well. So here's the driver. I can turn it off and on, switch back to 030 mode, etc., etc. Anyways, machine works. But as you heard, when I turned it on, there's no sound. No startup beep. The sound doesn't work at all. And we all know what that means. The capacitors. Let's take a look. So these are some of them right here. These still silver cans. These are the surface mount capacitors on these old Macintoshes. And like this one right here, there's gunk on the board. So this one has leaked. And there are probably other ones. There are more underneath the other components on this computer, like the power supply and under the hard drive chassis. They are leaking, and I need to replace them. All right, sorry for the shaky cam, but I got to get close up here. So taking the board out, I see signs of leaking all over the place. I mean, look at the corrosion. Those chip legs, they look bad. These caps have all leaked all around there. Over here, it's the same story. That's the one I pointed out earlier that had leaked, but these have clearly leaked as well. Even this little guy over here, while there's not a huge mess, look at the legs on there. There's a little bit of corrosion, and you can tell the contacts on each side of that capacitor, they look dull, so that means there's corrosion as well. Now look at this. These are actual large electrolytics, non-surface mounts. They look fine. In fact, there's a bit of corrosion on that trace there, but I think that's come from this mess here where all of these guys leaked. So the first thing I have to do is remove these surface mount caps and look at how bad the contacts are underneath. See if any traces are so damaged I'm going to have to run bodge wires. The fact that the computer seems to work fine right now, other than the sound, means that probably all of the traces are fine, and it's really just a matter of neutralizing the goop that's come out of here with some vinegar and cleaning up things as best I can, and then putting some new capacitors on. So my preferred method for getting these caps off is hot air, and I use some tweezers to gently lift the capacitor off the board as it melts the solder. Trying to use a soldering iron when the capacitors have already leaked and corroded the contacts, you're not going to get any heat transfer into the pads to get this thing off. So hot air is the only way to go. And then I cut little strips of aluminum foil here, so I will cover up things like the plastic slot connectors. I don't want the hot air to potentially melt those. For temperature on the hot air gun, I usually set around 350, and I put the airflow up as high as possible. This is a cheap eBay one. It doesn't really have a lot of airflow, but I use the smallest nozzle possible. And let's start with this capacitor right here. So what I find is if you heat the capacitor itself directly on top of it, you can actually pull the capacitor right off the board, leaving the legs behind. And then I can apply heat directly to the legs and the little plastic socket that's left behind, and that generally gets them off much easier. Once the plastic socket starts to melt, we know things are looking good, and I can probably lift the legs. Again, you don't want to use force. You want them to come off on their own. Here comes one. Both of them came right off. You see that? They lifted straight up without any difficulty. There's definitely corrosion on there, but luckily there's definitely some good parts of the contacts as well. Okay, let's do the next one. Gonna use the same method. Gonna point the heat directly at the top of the capacitor. Sort of weakens it. Okay, well that one actually came right off the board, which is not what I wanted, but luckily the pads are okay, I think. Although, wow, the one on the closer to on the left side here, this one on the left is very corroded. Oh, another one that came right off the board. Well, don't follow my methods here because they shouldn't be pulling right off the board. When things are corroded, sometimes the contacts are so weak, they come right off. All right, so my normal method of lifting them off isn't working so great, so I'm just going to do it very carefully. So just don't put too much force, and hopefully you don't cause damage. But there are just a lot of ways to do this, and you know, not everyone has their preferred method. So this one's gonna lift off and leave the contacts behind, like that, which is good, that's what I want. Basically, we're overheating the capacitor, causing it to kind of explode a little bit, which is fine. Come on out of there. You're almost there. Oh, this one is really putting up a fight. You can hear it bursting. Shit. That's a mess. Well, that didn't go exactly as planned. Luckily, I didn't lift any traces. So you can see these two come off. These two here came off, you know, with the heat properly, but this one sort of broke right off. So that's not ideal, but hopefully I can clean this up. Over here by sound, this looks pretty terrible, the shape. Luckily there's vias like that are right near the pads. So if I have to put bodge wires, I can, but I mean, look at that and that pad. They didn't seem to lift, but there's pretty much no pad left. So I'll have to clean this up with some IPA, some vinegar, and then I'll do some continuity tests. Here's the mess of leftover capacitors. Pretty gross, and it's funny using the heat method. Sometimes they smoke after you pull them off. They are not little happy campers. All right, so I've done some cleaning with IPA, and you really can tell, look at the damage that's been caused. See those traces? They're kind of hard to see, and some of the solder mask is coming off there, and similar situation up here by the sound. See, there's little bits that are exposed, and get this mess here. Hopefully the machine holds together once this dries and I get new capacitors on here. I'm probably going to cover up the little bits of exposed corrosion with some lacquer of some kind to just sort of seal it in. But I haven't even touched these contacts with to try to clean them up yet. I mean, that looks really, really bad. Some of these are going to be fine. So I need to try to touch up the solder joints, try to clean these up a little bit. The way I do it, I use my soldering iron and I set it for about 300. And we're going to apply some flux Don't have any paste right now, so this pen will have to do. So we'll put some flux on there. So I have the soldering iron set for 300 Celsius, and we're going to just test on this pad right here, because this one is not that bad looking. So just touch, scrape. Okay, I'm gonna need a little more heat. This is probably a multi-layer board. Gonna bring it up to 340. And the idea is we're gonna try to at least get some amount of a good... Okay, it's not terrible. So part of the pad is definitely damaged, but it seems to work. Too much heat can lift pads as well, so be careful with that. Yeah, alright, so there's some fresh solder on there. It's decent. I've sort of scraped away the bad stuff. That's the whole intent. You want to scrape off the bad junk that's on there. And I'm just going to try to clean these up a little bit. Yeah. See, I don't normally use braid that much because once they're corroded, I find that it just doesn't, they don't clean up that well. So put a little more. Yeah, so that's about how it was before I braided it. So I'm not even going to bother with the braid on the others, but it looks decent now. Fresh solder's on there. I'm ready for putting a new capacitor. So this board has two types of capacitors. There were 47 microfarad 16 volt. Those were the larger ones. And then there were some smaller ones that you saw on other spots that were 10 microfarad, also 16 volts. So what I'm going to replace these with is, instead of using electrolytics, I'm going to use tantalums. These new tantalums are good size. They should fit right on here. Plus these won't leak anymore. And apparently the new formulation won't catch on fire either, like old tantalums can. Well, I finished putting these caps on here. They weren't easy. 3 of the pads, strangely the negative on these 3, not the positive, was so corroded I had to put a little jumper wire. So I jumped it to there and there and there. This one went on without a hitch, and there's another cap that's down the board down here, and that one is fine. But yeah, it kind of went on. I haven't cleaned this up yet. I got to get some of the flux off. I'll use a little brush in the IPA, but hopefully this works. I tested continuity and it seems to be good. Now this area, luckily all the pads are in much, much better shape. And I've already installed these tiny little 10 microfarad 16 volt ones here and here. That went on no issue. Remember again, the white line on tantalums is the plus. It's different than electrolytics where the line is typically minus. And I have these 3 ready to go, and I'm going to put them on and show you how I do it. So first of all, I use some tweezers. I just grab the cap. Make sure you line it up correctly. I've already tinned the bottoms of the caps and the pads. And we just hold it in place. Hold it on like that. And then we do the same on the other side. Like that. And it's on. It's that easy. When the pads are not damaged, it's a simple process. So let's do the next one here. Right here, like that. That side's on. Just hold it in case it comes loose while I'm soldering the other side. I think that one doesn't have quite enough solder on it. So the thing is, when you put on one side, it might be slightly tilted up. And if that's the case, you just have to add a little extra solder. In fact, that's still looking a little crappy, so I'm going to touch that up. And the last one up here. This was probably the least damaged of all of these. Okay, so sorry, I didn't put that on centered quite right, so I'm going to move it. Go. Alright, so all the caps are on, and I put the motherboard back in here just sort of temporarily with the power supply. Let's power it on and see what we hear. Oh yeah! Let me hit interrupt. Perfect! That's what should happen if I hit reset. The sound is working again. So whatever the capacitors and all those corroded traces, I guess that did the trick. Let's see what happens on the monitor. There we go. So I don't have the hard drive connected or anything, so it's not going to boot. But we have sound. The computer still seems to power up without a sad Mac, which means it's working. And it may be crude because I used hot glue, but I did solder this on, so this battery is now connected here permanently, and the hot glue is just to stabilize it. Yep, that's pretty good, so I can get that battery out if I need to change it. And it will be underneath the hard drive, so will not cause any kind of issues, I hope. That might actually be too tall. So if I find out that I can't put the chassis back on, I'll have to fix that. This white connector here in between all of these is the headphone output, so I wouldn't be surprised if maybe it was these capacitors here that were causing the sound issue, and now that seems to be working. Okay, so I buttoned up the power supply. This normally has a black piece of plastic. I have this taped here. So I have the ATX power supply jammed inside of here. But unfortunately, it seems like the power switch circuitry is just not working properly on this computer. I'm not sure what's going on. I'm measuring the voltage. When you push this, it should give 5 volts out on the power supply turn-on pin, and it's not doing that. It just stays around 0.2. So maybe there's a lot of corrosion and damage right around that section of the board. There was a lot of capacitors that ran that circuit, so I have a feeling that probably got some damage, just doesn't work anymore. So what I've done instead, well, you see here, this is where you plug your monitor into. It's an output. But now there's a switch inside here, and if I turn this, so I have a fan mounted in here now, and that switch is now the power switch for the Mac. It's not great, but it's fine. And you know when you go to shut your Mac down and normally it turns off? Well, I guess this can tell that it's not working or something, because when you go to shut down, it just has a screen that pops up that says, it's now safe to shut your Mac off. Well, that's it for now on the Mac IIci. It seems to be working really well. I mean, other than the power switch not working and me having to do that little mod, the sound works perfectly. I've run this for several hours running stress tests. Everything's working great. The 68040 processor in fast mode actually generates pretty good speed improvements. Like this After Dark screensaver here, if I run this No 30 mode, it renders quite slowly. So it's really cool that this machine cleaned up really nicely and is working well. I hope you enjoyed this video. Put your comments and questions in the comment section below. I'm sure people will have lots of things to say about my technique of removing those caps, but that's what YouTube's all about. You can subscribe for more videos. I'd appreciate a thumbs up if you liked this video, and if you didn't, you can give me a thumbs down. Alright, take care. Thanks for watching. Bye.